Hi, this session is going to be about several tools which are handy for software development in C. The first one will be code coverage and the last one will be valgrind. So we will start with code coverage. Last time we talked about unit tests, and very often when you are doing unit tests, you combine it also with tools which show you how much of your code are actually covered with your unit tests, so-called code coverage tools. We use actually here the GNU compiler, the GCC, and the GNU tools. And for the code coverage, they use gcov. It's called like this. So what are you going to do? I'm going to show you how to actually enable code coverage, and it's just using some of the flags again, some compare flags. So you look at the makefile, and you can see I already added here the flags coverage. So when I'm going to compile, there will be not only the -G for debugging, but also coverage, which is going to generate some files which are used by the code coverage tools. By the way, it's also important to set the optimization -O to 0 if you do any debugging, if you do code coverage tests, because if your code is optimized, it's not going to show exactly all the time the best results. So it's just good to put it to 0 optimization. Okay, so I put this to the makefile. So I'm going now to compile the code again with this flag. So let's do it. I do again make test. It's a test that we did in the last session. And you see this one is used here. And now when I look at my directory, I will see several files. GCDA, GCNO, these files. And both these files, GCDA and GCNO, are created for each C file, which was sort of profiled with code coverage. By the way, we are not really interested in the Unity files. We are interested in these files. So when you run your GCC compile with the coverage, after that you have to run your code. And we already did it because make test first builds the code with GCC and then runs it immediately. So you can see it, I think, somewhere here. Yes, here it's being run, the test code. So we build it with code coverage and we run it. Then we can go and use the gcov tool. I'm going to use some magic flags, but you can see them actually if you just do gcov like this. You can see all these flags here. So I just picked up a set of them. I'm going to do min A, B, C, D, F, because I want to see a lot of information. And then I say I want to see it actually about my product file, the linked list.c file. Okay, so what happens now, the gcov is going to create another file which will show me the code coverage of my tests. I can see, for example, which is interesting is this file, the linked list.c. You can see that the at first function that we actually unit tested already. The last session has code coverage of 90.91%, so big one. And if you look at the whole file, it's about 52% because it actually did only the at first function, and the other functions were not really implemented, so it seems reasonable. Now I can do a look again what's inside of my directory, because this gcov actually creates a file that's called gcov, english.c.gcov, and you can just go and look at it. Okay, so when I look at this file, I can now see a lot of information because I switched all these flags on, so I want to see really everything. But the most important part is actually this one. This number 3, it tells me that this function was, during running of my test, executed 3 times. And that's correct, because I did first test when I only did the first adding of the first item to the list, and second test I did when I added 2 items to the list. So here is the first call, second call, third call. Okay. I'm not sure whether you see my mouse. So again, first call, second call, third call. Okay, this one is not really executive code, so it doesn't matter. Then I come here. This one is executed 3 times. And this one was not executed. And, well, that's true, because I didn't test on the fact what happens if I don't have enough memory. As I told you, it's quite difficult to test. So you can see it here on these hashtags, that it's actually not executed. If there is minus, it also means it's not executed, but this is only on the bracket. So, for example, here you can see not executed, no, 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 nothing, nothing, nothing. And I called 2 times clean. It's doing nothing, but I did call it, so you can see it. You can see it back here. It's the first call to clean, second call to clean. Okay. So we have this list. So it shows us what's happening. By the way, it also shows you how many times which branch was hit. So, for example, this branch here was taken 3 times. This was taken 2 times. That's correct, because we did 2 times at first item of the list. And this branch was taken once. I don't see the code for it, but it's just like that. So that was very shortly about GCOV. There is also a graphical interface for GCOV, and it's called LCOV, like this. If you want to use it, then you have to actually run this command install. That's the generic command to install something in Linux. But I already installed it, so I don't need it. I just to look at the internet, what you have to do to run the LCOV, and I put it in this file. So there are 3 commands. The first one is going through all your directories and set all the counters to 0, as it's here. Second one is going to look at all these nice files that you created here for Chico and create sort of an info file. And finally, this one is going to create HTML file. What's exactly happening, I don't know, but it's not so interesting. So what I'm going to do, I'm going to run this ilcov test. You can also do exactly the same just by running these 3 commands. Okay. And now what I see is that there is a file by the many other files. So you can see, if you know HTML, that all the CSS files and pictures or whatever are created. But this one is important, the index HTML. And if I want to look at it, I can just go Firefox, for example, and open the file. And I can see exactly the same information that I see here, but it's just a little bit more modern way. So these are this code coverage for a report for Unity. Not interested product. That's interesting for us. And test. If you look at this, you can see the C file, and yeah, it's almost, yeah, it is 100% because we did run all the tests. All the code here was run. So let's go back. Let's to product and to linked list, and you can immediately see again that we didn't run this one. We didn't check on the raw malloc, and that the blue lines you can see that what was run by our tests, and the red ones, these functions were not run, and this one was run, so it's blue again. It's just a nicer way of doing the same, but yeah, you will get a lot of temporary files like this, so it will be a little bit crowded in your directory. So that is a short introduction to coverage. Maybe something to a little bit more to say about code coverage. It's really nice to have the high code coverage, but and sometimes it's also a little bit addictive. So people are trying to really code and make the unit tests all the time, so the code coverage is as good as possible. But please be pragmatic about it. It doesn't mean that if you have a very high code coverage, that you have also a right code. But the chance that it's good, it's much higher because you tested it a lot. And the last one is the valgrind. Maybe you've already seen that. You can uh, install it in the same way like I showed you for Ilko. So just do sudo apt get install valgrind. I'm not sure whether it's here or not, but okay. And then you can run valgrind. How do you run it? You just take the executable. Please take this one, because this one is actually executable that's running test with your code. Yeah. So, and let's have a look what's happening. Okay. If I look here, it's going to look at the memory allocation that I have done. It's a very useful tool. It tells me how much memory I did allocated during my tests, during running of my code. But it also tells me how much of the memory I never freed, so they are lost. And once you are going to hand in your assignment, I really want you to have these numbers on zero. I don't want to have any memory leaks. So let's have a look what's happening. It's pretty obvious. I did mallocs here. So I called this function 3 times and there are 3 mallocs. 3 blocks. It's probably those. But I never freed it. I did call the clean, but clean is doing nothing. So I think once you implement the clean function with cleaning your list, so there will be some freeze, then this test will also show you no memory leaks. But implementation of this function I will leave to you. The valgrind is not only showing you memory leaks, it's also going to show you a lot of memory errors that you do. So if you have very bad memory errors or whatever, and segmentation faults or these kind of things, it's going to show you where that happens. So, for example, if you read behind the array or if you write on a part of memory which you are not allowed to write on, it will show it to you. So it's also extremely useful to solve the memory problems. Okay, so that's about what I wanted to show you today about code coverage and valgrind and the tools. And by the way, before I forget, you are using the GDB debugger. So don't forget, once you use that one and you want to debug your tests, this is what you have to debug. So it's GDB tests. And then you can go to, I don't know, for example, at first, I think it's called, yeah. And you can run it, and it's just, don't forget that this LL underscore test files, that's the unit test inclusive your code. So it's the one that you have to run in GDB. I'm telling you because some of the students didn't find this out, so it's just mistakes I've seen many times. But now that's really all. Thank you for listening.